My name is Chaitanya. I'm from section ITA and my roll number is 19. Next we have my topic for Tech Talk, that is algorithm design. An algorithm is a procedure to solve a particular problem in a finite number of steps for a finite sized input. The algorithms can be classified in various ways. They are implementation method, design approaches, other classifications. Classification by implementation method. There are primarily three main categories into which algorithm can be named in this type of classification. They are recursion or iteration. A recursive algorithm is an algorithm which calls itself again and again until a base condition is achieved, whereas iterative algorithms use loops and or data structures like stacks, queues to solve any problem. Every recursive solution can be implemented as an iterative solution and vice versa. For example, the Tower of Hanoi is implemented in a recursive fashion while stock span problem is implemented iteratively. Exact or approximate algorithms that are capable of finding an optimal solution for any problem are known as the exact algorithm. For all those problems where it is not possible to find the most optimized solution, an approximation algorithm is used. Approximate algorithms are the type of algorithms that find the result as an average outcome of sub-outcomes to a problem. For NP-hard problems, approximation algorithms are used. Sorting algorithms are the exact algorithms. Serial or parallel or distributed algorithms. In serial algorithms, one instruction is executed at a time, while parallel algorithms are those in which we divide the problem into subproblems and execute them on different processors. If parallel algorithms are distributed on different machines, then they are known as distributed algorithms. Classification by design method. There are primarily three main categories into which an algorithm can be named. In this type of classification, they are as follows. Greedy method. In the greedy method, at each step, a decision is made to choose the local optimum without thinking about the future consequences. Examples are fractional, knapsack, and activity selection. Divide and conquer. The divide and conquer strategy involves dividing the problem into subproblems, recursively solving them, and then recombining all of them for the final answer. Dynamic programming. The approach of dynamic programming is similar to divide and conquer. The difference is that whenever we have recursive function calls with the same result, instead of calling them again, we try to store the result in a data structure in the form of a table and retrieve the results from the table. Thus, the overall time complexity is reduced. Dynamic word refers we dynamically decide whether to call a function or retrieve values from the table. Example 0, 1, knapsack and subset sum problem. Linear programming. In linear programming, there are inequalities in terms of inputs and maximizing or minimizing some linear functions of inputs. Examples are maximum flow of directed graph, reduction, transform and conquer. In this method, we solve a difficult problem by transforming it into a known problem for which we have an optimal solution. Basically, the goal is to find a reducing algorithm whose complexity is not dominated by resulting reduced algorithms. An example, selection algorithm for finding the median in a list involves first sorting the list and then finding out the middle element in the sorted list. These techniques are also called transform and conquer. Branch and bound. This technique is very useful in solving combinatorial optimization problems that have multiple solutions and we are interested in finding the most optimum solution. In this approach, the entire solution space is represented in the form of a state space tree. As the program progresses, each state combination is explored and the previous solution is replaced by a new one if it is not the optimal than the current solution. Example, job sequencing and Traveling salesman problem. Top-down approach. In the top-down approach, a large problem is divided into small sub-problems and keep repeating the process of decomposing the problems until the complex problem is solved. Bottom-up approach. The bottom-up approach is also known as the reverse of top-down approaches. In approach different, part of a complex program is solved using a programming language, and this is combined into a complete program. An algorithm has the following characteristics. Input. An algorithm requires some input values. An algorithm can be given a value other than 0 as its input. Output. At the end of an algorithm, you will have one or more outcomes. Unambiguity. A perfect algorithm is defined as unambiguous, which means that its instructions should be clear and straightforward. Finiteness. An algorithm must be finite. Finiteness in this context means that the algorithm should have a limited number of instructions, that is, the instructions should be countable. Effectiveness. Because each instruction in an algorithm affects the overall process, it should be adequate. Language independence. An algorithm must be language independent, which means that its instructions can be implemented in any language, and those instructions should be able to produce the same results. Thank you.